The other day, Pat Shaughnessy tweeted a question he had about the syntax around references in Rust closures. While there's a pretty straightforward answer to his question, the simple code exposes some interesting details of how Rust works. Let's take a look. Pat's code is pretty simple. There's a string we'll call item, and a vector of strings we'll call collection. Pat then calls iter on collection. This gives him an iterator. He'll then call find on that iterator, which takes a closure. As we iterate over the collection, the closure passed to find is called with each element. When the closure returns true, we stop iterating and return that item. Pat's question centered around the use of ampersand in the closure's argument list and asterisk in the closure's body. Let's explore what these elements are for and why they're needed. First, let's delete both items and explore what the compiler can tell us about our code. Hovering over the argument to the closure, we see something interesting. We have an ampersand string. What this means is that the argument to our closure is not a string, but rather a reference to a reference of a string. Why is this? First, let's look at what our vector we called collection looks like in memory. The vector struct itself lives on the stack, but it has a pointer to the various strings which live on the heap. It's important to remember that collection owns the strings that live on the heap. This means it's responsible for determining when to destroy those strings. In Rust, only one thing can own a piece of data at a time. So unless collection gives up ownership, nothing else is allowed to own those strings. In other words, other things can only reference those strings. Now let's look at what calling iter does. Looking at the docs for iter method on vector, we see that it takes a reference to self. This is our first clue to what's going on. The iterator can only have a reference to collection, and thus can only have references to what collection owns. This is because if our iterator were to take ownership of the elements inside the vector, then there would be two owners of the strings inside the collection vector itself and the iterator, and this isn't allowed. Rust guarantees only one thing can own a piece of data at a time. Looking at the return type of iter, we see it returns a struct called I iter. This struct is the concrete type that allows us to iterate over collection. Iter is generic over some type t, but for our case we know that t is string, since our collection is a vector of strings. Now let's look at the docs for how I iter implements the iterator trait, which gives it all the iterating functionality we care about, including the find method. We can use a bit of movie magic to replace the generic type t with the specific type we know we're going to iterate over, string. With string in place, we can see something very important. The type of item is an ampersand string. This means as we're iterating over collection, we're going to yield references to strings instead of own strings themselves. We've already seen why this needs to be the case. If we were able to yield the own strings themselves from our iterator, then we'd be giving ownership of that string to some variable, but our collection vector still owns those strings. Now let's take a look at what calling find does. We can see that the predicate closure takes an argument of ampersand self : item. If we do a little more movie magic and replace self item with a concrete type we'll have, ampersand string, we see something interesting. Our closure will take an ampersand string. In other words, our closure can refer to the reference inside the iter struct, which itself is referencing the string owned by our collection vector that lives on the heap. This is why we saw in our code that the argument to the closure passed to the find method was an ampersand string. Now let's go back to Pat's original question and take a look at that syntax. As the code stands right now, the argument to the closure is an ampersand string. However, we need to compare it to item, which is an own string. We have several choices to choose from to get this to work. First, we can make item itself an ampersand string by adding two ampersands. If we don't want to do that, we can instead dereference our argument twice to get to the actual string. The last choice we have is doing the dereferencing in the closure argument list. Because arguments to closures are patterns, we can use the ampersand pattern to say, we know the argument to this closure will be an ampersand double reference. Please match against that and bind the thing being referenced to the name provided. We get an error here because this syntax deliberately takes ownership over the item being referred to. We've already seen why we can't do that. Pat made the choice of mixing these choices together and using pattern matching to eliminate one reference and then asterisks to eliminate the next. Arguably the most idiomatic thing to do is to pick one strategy and stick to it. In this case, I'll keep the double asterisk reference. and we're done. Thanks for watching.